This conference will now be recorded.
Very good evening, students. So in the last class, we had discussed a little bit about Kirchhoff's law. As you know, we had discussed Kirchhoff's current law and voltage law. Current law is actually based on conservation of charges, and second law is based on conservation of energy. So that's what we had discussed, and we had discussed how to solve numerical problem. Today we'll actually do a lot of numerical problems today. So just for recap, for the recapitulation, I am just writing this current law. See, all the currents which are just coming into this point or junction, those are taken to be positive. Okay. Others you can take negative. Like which one are going out of this junction, you have to take negative, and sum of all those will be 0. Or in other words, you can do one thing, like how many are coming into, sum of them will be equal to the sum of the currents going out of the junction. So this is the current law. Okay, so this will be using while solving numerical problem, and that time I'll mention how we are using KCL. Now KVL, you know, there are few things to remember. First of all, what is KVL? KVL is a sum of the change in voltage will be 0. Or in other words, if you have in a circuit, resistors and batteries, more than one battery and resistors, etc., then all the EMF you have to take sum of all the EMF, that will be equal to sum of the voltage drop across each resistance. Okay, across each resistance. So that will be, suppose EIRI, and this is summation of this. Okay, so this will be another form of KVL. Okay, so we had discussed that day there are few rules like direction rules. Suppose when, see, there will be a situation will be going through. Suppose if I go from A to B, then the current is flowing from positive terminal of the battery, so this EMF has to be taken as positive. When I go A to B, in this case, look, the current is as if flowing from negative terminal, so in this case the EMF has to be taken as negative. In case of resistor also, when we are going through this path A to B, if the current here actually this is change in the voltage, that's why it is negative. But what we will do, we'll just take IR. Okay, so please don't get confused with this. This is actually VB minus VA. VB is lower potential, VA is higher potential. So that's why it is negative, it is said here, but we'll see, we'll say VR. VR means voltage drop across R, so that you can take as I into R. And see, when we go from, like, go through the path A to B and also current flowing in the same direction, then it will be just IR positive. Okay, this is what I had to mention here. And here also, look, in this case it is, see, it is opposite, in the sense the voltage is actually greater here, that's why this is high potential, this is at low potential, that's why it is positive. The change in the voltage is positive. But see, in this case, suppose we are going through the path A to B, when we are going from going through a path from A to B, voltage drop across this resistor I have to take as minus I into R, because I'm going from A to B, but the current is flowing in the opposite direction. So this is what we will follow. Okay, don't get confused with this change in the voltage. Okay, all right, because we are going with this, we'll just sum up all the voltage drop across the resistors and all the EMF, all the EMF of the batteries. Okay, so then see, I will not discuss this one. We'll just go for an example. See here you have to find out. See, this kind of circuit will be given and you will be asked to find the current in each branch. Find the current. Current in each branch. Branch. What is branch? We had discussed that day. So branch is actually a portion of the circuit between two junctions. Okay, so suppose here is one junction, here is another junction, so this is a branch. Similarly, this AF and C, these are two junction points, and so resistor 3 is actually a branch. Okay, like that. So we have to find out the current in each branch. So in this case, you know what we should do? In general, whenever there are more than one battery, let us take the currents are coming out. Let us take that currents coming out of the positive terminal. In that way, we'll take. So we'll take this. Suppose this is current I1. Okay, and see all the way current going up to here. But at this point, after this point, the current is actually getting divided into two. Like it is going into two branches. There are paths like EA path and there is a path EF path. So so I'll just take that current direction is I2 here. That means, you know, the current I1 was there. The whole current that is getting branched into I2, and this will be rest of the current, that is I1 minus I2. So I'll go with this convention. So here, see what we have applied here at this junction point E. We have applied KCL. So we have applied KCL where at E junction point. Okay, now see, now what we have to do, we have to take two loops. Here there are two loops. We can see that there are two closed loops, so the same current will flow up to here. Okay, then see it will go all the way here. See here I1 minus I2, and see this I2 will come here. Okay, come here, and then this will add up to I1. This will flow like this. All right, so I'll just take a loop one. Suppose L1 loop 1. I'm taking, see, from C to B, or B, you start B from E. So I have a loop B, E, then F, C, B. This is a closed loop. Okay, another loop I can take in the similar way, like this. This is L2, suppose. So this is L1, loop 1. So this loop is going loop. Okay, let me just do this. So loop 2 is, see, it is going from E to A to D, D to F, and it is coming back to E. So this is a closed loop, another closed loop. So here what we have to do, we have to apply KVL to find out two relationship, current voltage relationship. So there, in fact, at the each branch we will be applying Ohm's law itself, but we are, see, here we will be applying KVL. So suppose I take, see, this loop, BE, this loop. So in this case, first of all, let us find out what is the voltage drop. See IR. So this sum of the voltage drop at like across each resistor we have to find out. So what is the current here? I have just taken I1 here. I1 through this resistor 2. And see, I'm going from B to E, and also the current is flowing in the same direction B to E. That's why I will take that as positive. So I1, this will be 2 into I1 with the positive sign. Now go to E to see E to F. E to F, I'm going E to F. Here I have taken that current through this 1 ohm resistor to be I2, and also see I'm going from E to F, and current is also flowing from E to F. So that's why here also we will be taking, so 1 into I2. Now look here. Now I'll go to F to C. F to C. Here also I'm going from F to C, and the current across this current through 3 ohm resistor is I1, which is flowing from F to C. So that's why this also will be positive only. And this, see, in this loop, so this one. So we have already found out the voltage drop across. So this will be summation of all the EMF of the batteries. So here see, this is only battery, that is 9 volt here, 9 volt. Okay, so this is 5 I1 plus I2 is equal to 9 volt. So this is equation number 1, say equation number 1. Now I'll go to the loop 2. See, I have two unknown quantities, I1 and I2. So to solve or to get the values of I1 and I2, I need at least two equations. At least two equations I need. So in the loop 2, see here, I'll go from E to A. So there is only battery. I'm just finding out first what are the voltage drop across the resistors. So A to D, excuse me, A to D, there is no resistor over here. So this is only conducting wire. So there is no voltage drop across A to D. Then D to F. D to F, there is a resistor, and how much is the current? See, I am going from D to F, and current also is flowing in the same direction. Current is I1 minus I2 through this. So I'll write 3 into I1 minus I2. Then I go F to E. F to E. See, in this case, current I2 is flowing through this 1 ohm resistor. The direction of the current is E to F, but I am going to E from F. So here current direction is opposite. So what I have to take, minus, say, 1 into I2, and this will be equal to the EMF of the battery. But in this case, you look, see, I have taken the current in such a direction that this EMF is also positive, because current is flowing. See, current is coming out from the positive terminal of the battery. So this is also 6 volt is positive 6 volt here. So here let us simplify. So 3I1, okay, this is 3I1, and 3, this is 4I2. 4I2, this is equal to 6 volt. Okay, so now I have got two equations. I'll just take them in the next page. See, as far as I remember, 5I1 plus I2 is equal to 9 volt. Is equal to 9 volt. And in the second equation, we had 3I1 minus 4I2. 3I1 minus 4I2, that is equal to 6 volt. Okay, volt anyway we don't need now this volt and all. Okay, so I'll just I can just do one thing. See, I can multiply 4 here. Okay, both sides. So this will be 4. This will be 4 into 5. Okay, and then add them up. See, if I add this will be 42. 9 into 4, 36 plus this. So this will be 42. This will cancel up, and see there, this is actually 23 I1. Okay, so somehow these values are a little bit odd anyway. This is this. Okay, we can actually divide so kind of, see, this is nearly 1.82 ampere. Okay, so we can now just put the value, or otherwise we can just do the same thing again. Okay, better to do the same thing again. 5 I1 plus I2, that is equal to 9, and this is 3 I1 minus 4 I2, 6. So what I do here, I multiply 3, here I multiply 5, and then I have to subtract. Okay, I have to subtract then. Okay, so what we will get from here, see, I have, see, this will be 27, this will be 36. If I subtract this, this will be minus 3, and see, if I subtract this, it will be anyway 3 into 5, and this is 5 this, and this will be 5 into this. So 20, this will be, if subtract, this will go, this will be positive, so it will be actually 21 I2 is equal to this. Okay, minus 3. So this would give you I2 is equal to minus 3 by 21, or 1 over 7 ampere. Okay, I2 will be minus, that means what, current will be flowing. So we have taken E to F, but current will flow F to E. In this direction, current I2 will flow. So I2 will be 1 over 7 ampere. Okay, so these values are a little bit odd, but anyway, the main point is to write the equations, equation 1 and equation 2. This is main point. Otherwise, things are as usual. You have to just simplify and solve. Okay, solve some equations, that's all. So we'll just go to next problem. I'm just first taking simple problem so that your concept will be a little bit strong in the beginning. Like, just build the concept, then we'll solve complicated problems in other classes. Okay, so suppose you have a circuit given like this. So this is cell 1, which has EMF 12 volt and internal resistance. See, this is the internal resistance R1. This is given as 2 ohm, and this is the battery E2, 6 volt, and this is the internal resistance R2 is equal to 1 ohm, and this is 4 ohm. The question is, find the potential difference across each cell. Question is, find the potential difference across each cell. And the rate of energy dissipation in R. Okay, so this is the question. So how to solve this problem? See, find the potential difference across each cell. What does this mean? See, these are actually batteries where EMF is given, right? That means, you know, when you have a cell, these are electrodes and dipped into the electrolyte. So this is suppose positive terminal or P here, and this is negative. Okay, so what is given is the EMF is 12. That means when the these are actually not connected into the circuit. Okay, and see there are internal resistances, suppose E1 R1. So potential difference between these electrodes will be actually V is equal to E minus IR, if this R is internal resistance. So you have to find out what is the current through each branch. Then you will be able to find out the potential difference across each cell. So this is what is given. You should not actually get confused with this values 12 volt and 6 volt. You will be a little bit surprised why this question is being asked. Actually, this is the thing they have asked. V is equal to, you have to find out. EMFs are given. EMFs are given, but voltage difference is not given. So that you have to find out as V is equal to E minus IR. That means you have to subtract the drop in the inside the battery due to internal resistance. See, as usual, what we'll do? We'll do it as usual. See, since there are batteries like this, I'll take this is I1 and this is current I2. And see, at this point we have to apply junction rule. And I'm just giving a name. Suppose this is A point. Okay. Then this is B, C, D. Then this is E, F. So these are the names. So there are two closed loop. You can see that. And in fact, you can take other one. The whole one is one closed loop also. So that you can take. So I have two unknown quantities. See, through this, the both the current will enter. So I1 plus I2 will enter through this. Okay, this, let us say this is I3 for the time being. Okay, or we'll directly write also while applying loop rule. So now we'll apply loop rule ADBC, sorry, AD, ADCBA. So AD loop, see this is suppose loop one, and how we are going like this, okay, and this will be loop two will go like this, okay. So for loop one, see what are the voltage drop across the resistors for loop one. See how many resistors are there in loop one. See this is R1, okay, and see here what will be the current flowing through this. See, as soon as it come here, see I2 will be here this way, and I1 anyway will be branched here like this. So this will be 2I1, 2I1, 2 is the resistance, I1 is this current through this, 2I1, and here it is, see how much it is. It is actually 4. See, I'm going from D to C, C to B, B to A to D. See, C to B in this path, the current is also going in that direction only. So that's why I have taken 2 into I1. And now see, in this branch A to D, there is a resistance 4 ohm. So there also current is flowing in the same direction A to D. So that's why I can write 4 into I1 plus R2. Sorry, I1 plus I2. So this will be equal to the EMF of the loop. See, EMF of the battery of the loop. See here only one battery, that is 12 volt, and EMF, sorry, so current, see direction wise you will see current is flowing out from the positive terminal. We'll take that as positive this. Now from here we can just solve, like simplify bit. So this will be 6I1 plus 4I2, that is equal to 12. So we can give a name here, equation number 1 maybe. Now we'll go for the loop 2. See, I'm just taking now F to A. See, loop 2 I am taking L2 as F to A, D, E, F again. Okay, so I'm going from E to F. So in this direction I am going. What is the current flowing through this? That is the I2 only. So this is 1 into I2. Here this one again. So here also across 4 the same voltage drop will be there, right? But in this case also this will be positive. So 4 I1 plus I2. Okay, and this will be equal to 6 volt. So this 4 into this 5I2. 4I1 is equal to 6. Okay, so again we have got two equations, 4, 5, 6. Okay, 4, 4, 6. Oh, 6I1, 4I2 is equal to 12. 6I1, 4I2, 5I2, 4I1, 4I1 plus 5I2. This is equal to 6 again. Okay, we can do one thing. We can just take 1 out from here. Let me just do in this way first. Okay, but that also will get complicated. Better to do. Okay, so multiply 2 here, both sides. So this will be 2 into this. This will be 2 into this. And here let us multiply 3. And then what? Then let us subtract. Subtract means this will be 0. So this will be minus. So you have 8 and this is 15. So minus 7i2. So this is 21st. This is 6. So I2 will be minus of 6 by 7. Minus of 6 by 7. So what does that mean? Minus of 6 by 7. See I2 we had taken this way, right? So we have taken E to F, but current will flow in this direction. The current will flow in the E to E. See in this case also current will flow in the direction F to E. So when I get negative, any current negative, that means we have taken the direction in the opposite direction. Okay, so we have found out that current will be minus 6 by 7, and that means the current direction, in this case we have taken E to F, but actually current will be flowing from F to E. So that is what it is. Now we have got one current, then we have to find out the other current also. So we can just see, I have 6i1 plus 4i2 is equal to 12. I can actually use this here. 6i1, 4 into 6 by 7, this is 12. 6i1, let it be like this. So this will be 12 plus 24 by 7. So this will be 84 plus 24 divided by 7. 108 divided by 7, 6i1. Okay, so this will be 6i1 is equal to this. So I1 will be so 18 by 7. I1 will be 18 by 7. So we have solved for the currents. Okay, so I'll just write now. I have found out I1 is 18 by 7 and I2 is minus 6 by 7. So these are the two things we have found out. Now we have to find out EMF across each. So EMF, see, sorry, voltage across each. So V1 will be U1 minus, current is flowing here, how much? In this I have taken I1, right? So I1 minus I1 into R1. So R1 is 2 ohm and this is 12. 12 minus this is 18 by 7 into 2. Okay, so potential difference across each cell. let us see how it goes. This will be this is like this, okay, by 7. So 8 4, so it is 48 by 7. So V1 is that, and what will be the voltage? Let us see. For this is 2 minus I2 R1. Okay, so R1 is 1 only, and this is 6. See this current, I have got minus, right? So I'll take minus itself. Sorry, I2, 6 by 7, right? So this will be positive. So this also will be 48 by 7. So voltage drop across, or potential drop across its cell, is 48 by 7 volt. Okay, then we have to find out potential difference across R. I'll just clean everything because I have already found out currents and all. I'm not keeping these equations. Let me do it here itself. Okay, so yeah, so I have to find out potential potential difference across capital R. This we have to find out. So R is 4 ohm, it is given 4 ohm. So what is the total current in that? So this will be actually V of R is equal to I1 plus I2 into 4. So I1 is how much? I1 is 18 by 7. I2 is minus 6 by 7. 18 by 7 minus 6 by 7 into 4. So this will be 12 by 7 into this. So this will be actually this one, 48 by 7 only. Okay. Now what is the, actually that is obvious. Okay. 48 by 7, that is obvious because the voltage drop across its, or potential difference across its cell is the same as that. Okay, same as this thing. We would have done this thing, like we would have found out voltage potential difference across this capital R, and then we can directly write what is the potential difference across its cell. Okay, we don't have to do this then, because only register is for which is connected to the external circuit of the battery. Now power dissipated across R. So power dissipated across R will be I square R. So what is the current? Current is 12 by 7. And what is the resistance? Resistance is 4. Okay, this is 144. This is 49 into 4. Okay, so this is the one, and eventually if you just divide this, you will get nearly 11.5 11.75. So this is the power dissipation across R. Power dissipation across R. Across R. Okay. All right. So we'll take up few more problems. Let us see. Next problem we'll take up. Now let us take up this problem. I'm just drawing the figure. Let me. So this is 3. Okay. Another resistance here. Okay. So this is 5 ohm. This battery has 12 volt potential difference. This is 6 volt. This is 3 ohm resistance, and this resistance is 2 ohm. Okay. So let me just give name A. This is B. This is C, D, E, and this is F. The question is, using Kirchhoff's law in the electrical network shown in this figure, calculate the values of see I1, I2, and I3. So this is given I2, this is given I3, and this is given I1. So you have to find out the values of I1, I2, and I3. So this you have to do using Kirchhoff's law. So this is very simple, right? No need to worry about directions. The directions already given, and current also. How do I use? So that is also given. See here, actually one thing you have to do. See here, as this current go all the way from this battery to C and to B at this particular point. Okay, so this again the I1 current is coming all the way from this battery to A to B. Okay, at this point, this I3 is obviously sum of these two currents, I1 plus I2. So this is what we'll take. Okay, and then again, see at this particular point, current will be divided into again two branches. Okay, then it will go I2, this will go like at E, the current will come as sum of this C. B to E, current will come as sum of this I1 and I2, and after E, again the current will be branched into this. So I'll take this loop. Okay, this is L1 say, and I'll take this loop in ultra direction, and let us say this is loop 2. Okay, so I'll just name as loop 1. That means I am going from where? Say I'm going from A to B to E to F to again A. This is a closed loop. Okay, so if I apply KVL in this loop, so summation of the voltage drop across the resistor. So look, this is 2 into I3. I3 means I know this is I1 plus I2. I'll directly write. Okay, I'm going from A to B, B to E. That's why I have taken positive here. Okay, 2 into I3, that means this. And then this 5 into I1. This also will be positive only, 5 into I1. And see the battery, from the positive terminal only, current is going, see I'm going from F to A, F to A. See, that's why the current is flowing from the positive terminal of the battery. I'm just taking that as positive 12 volt. All right, now this is the first equation. I can just do a little bit of simplification. So 7I1 plus 2I2, that is equal to 12. Then let us go for loop 2. Okay, loop 2. Let me do that loop 2 here. So this I3 is equal to I1 plus I2 that I have taken. So loop 2 is what? Loop 2 is, see, I'm going from D to C, B, then E, then again D. So this is the closed loop. All right. So look, this is current. I have taken anyway positive because I'm going from D to C. Current is also going in that direction. So 3I2. So B to C and then B to E. B to E, I'm going from B to E. Current 3 is also going B to E. So I'm taking this as positive. Then what is the battery terminal? See, battery, from the battery terminal, current is flowing out from the positive terminal. So I'll take 6 volt itself. So this equation I can name as equation number 1, and this simplifying. See, this is 2 and this is 2. So 3, 2. So 2I1 plus 5I2. This is equal to 6. So I have got two equations. You look here, 7I1 plus 2I2, that is 12. Okay, then again here it is 2I1 plus 5I2 will be 6. Okay, so we have to solve this equation. Let us try to solve it. 7I1 plus 5, yes, 7I1 plus 2I2. 7I1 plus 2I2. This is equal to 12. Okay, other one will be 6 anyway. So that is 2I1, 5I2. Okay, so let us do one thing. We'll just strike this I2. So let us multiply 5 here and 2 here, and then subtract. So 5 into this here, there 2. So I have to just subtract, right? So this will be 31 because this is 4 and this is 37. Sorry, 35. So this will be 31 into I1. 31 into I1. This will strike out if I just subtract. This will be 5 into 2 and this will be 5, 25. So here it is 12 and this is 60 minus 12. So this will be 48 somehow. Okay, 48. So let us see whether we are getting or not. 48. So I1 will be 48 by 31 ampere. So this is actually correct answer. Okay. Now I2 will be able to find out in the similar manner. Better to go with this itself. Okay. Let us rewrite the equation. This 5 I will just strike. This 2 I'll strike. This also I'll strike. This 5 I'll strike out. So this is the equation. So I have found out anyway I1. I'll write this somewhere else. This will be my equation. So I1 we have found out as 48 by 31 ampere. Okay. Now I have to find out I2. So I have to eliminate I1. So here I will multiply 2. So this will be 2. Here I will multiply 7. Here 7. Here 7. And then subtract. This will cancel out. So here this is 7, 5, this is 4. So this will be actually minus 31 I2. So here it will be actually see 24 minus of 28, I hope. Sorry, 18 minutes. Okay. So this is 18 minus 18. Okay, so I2 will be actually 18 by 31. This is the thing. So this is I2. Then see what will be I3? I3 is sum of these two. 48 by 31 plus 18 by 31. Okay, this is in ampere. So this will be 66 by 31 ampere. Okay, so these are the values of the current. So I think this is the way to solve various numerical problems. I'll take another problem and then I will conclude the session. Okay, so question number 4. Let me draw the figure first. Let us give the name A, B. Then here it is C. This is D, E, F. This time the naming is just opposite. So here this is 1 volt. This is 2 ohm. This is 6 volt. This is 3 volt. This is R1, unknown resistor. We'll see what the thing is. This is 3 ohm and this is again R. Okay, see this arrow is given like this. This figure arrow is given. Okay, let me make it nicer. Like this it is given. Okay, so the question is use Kirchhoff's rule to determine the potential difference between the point A and D. So you have to find potential difference across A, D. Across in the sense I mean to say between A and D. Potential difference. Find potential difference between A and D. So this is the question. No current. Okay, there is a condition. When no current flows, no current flows in the arm BE, in the arm BE of the electrical network shown. Okay, so BE is this one, right? When no current is flowing through this BE, what is the potential difference between A and D? So that is what we have to find out. Okay, I'm sorry, here there is 4 volt. This is 4 volt. Okay, so this is what we have to do. See, when there is no current through this, I can just erase this itself, because this is, see, if no current is flowing through BE, then I can just ignore this. Okay, let us ignore this. Okay, so if we ignore that, then if we find out what is the current, what is the current flowing in the circuit, let us do it arbitrarily. So let us say the current is flowing this way, some I current is flowing in the circuit. Okay, so this will be 2I, this will be, I'm going through this way. Okay, but one problem is there. In this case, there is one problem. This capital R is not given. That is the problem. Okay, that's why we cannot do that. Okay, we cannot do in as usual manner. So what we'll do, let us keep this, the original circuit will bring back. The original circuit was, there was a resistor R1, there was a battery 3 volt battery. Okay, this was R1 resistor. See, in this case, since no current is flowing through BE arm, let us do one thing. Let me take this, the current is flowing is I itself here, and since no current is flowing in this way, the same current will flow in this way also. Okay, so this is the only way to do. Let us see. Okay, let us see what it is. So in this loop, see, loop, I'll write this is L1 and this is L2. L1 loop, for L1 loop, I'm just going in this way. So I current is flowing, I have taken already. So look, this IR1, okay, IR1 plus 2I plus 3I. This is equal to, say, this is current I have taken this way. So I'll take this 3 minus, here it is, I'm sorry, this is positive. This also will be positive, 6 volt, and this also will be positive. Okay, see, in this case, one thing, you look the current through this this is 0, so I'll take voltage drop across this is 0, and this is 5I. This is equal to 10 volt. So I will be actually 2 ampere. So we have found out what is I. So 2 ampere is the current. Now if we go from A to D, I go from A to D along AFD. See, I go A, F, and D like this. If I go, see, I go from A to D, and the path is AFD. Okay, so here, see what is the drop here? This will be 2 into 2. And what is the voltage here? This will be 1 volt. And what is the drop here? 6 volt. And see this point and this point, all the points are the same. See, E point and D point are same. Okay, so E point and D point is same. So BAD will be this actually. So this will be 4, 5, so 11 volt. Oh, I have taken 2, okay, 2 volt. I have to take, let me see whether I have done some mistake in the polarity somewhere. Polarity. This is the voltage. Okay. 3 into 2, that is 5. Okay, let me write once again. A to D. I'm going from A to D. I'm going from A to D. So A, see here, BAD. Voltage drop across this is 2 into 2. Okay. A, F, and D like this. Okay, let us see. This is 6 plus 6. AFD. Okay, so I have to take minus 1 here so that it will be 9 volts. Okay, so this battery. All right, so This will be the answer. Okay, so so this is the answer. So 9 volt will be the voltage or potential difference between A and D point. So we'll stop it here for today. Next day we'll take up the instrument parts of this, like meter bridge, Wheatstone bridge, etc., potentiometer, etc. will take in the next class. So thank you for your patience. Bye for today.